All right, so what we have here on this wall, we have 28 4-watt LEDs. Over there, what was behind me, I have 18 and 4, 22, okay? So we're gonna start with my transformer right here. This is a 150 watt transformer right here. We're gonna hook it up. And I'm gonna hook it up to this guy. 22 and 28, which is 50 4-watt lamps. If you do the math, that's at least 200 without a power factor. All right, we want to take our amp probe, and we're gonna check some readings here. So first of all, I think I'll check the secondary. And on the secondary, I have 12.6 amps. Okay, I'm gonna write this down so we do not forget. Secondary, I'll go this way to the left. 12.6. 12.6. Now we're going to check the primary. Come on over here to the primary. I have 1.3. 1.3 on the primary. All right, so now what we're going to do is we got 12.6 on the secondary, 1.3 amps on the primary. And now what I want to do is I want to disconnect it. And we're going to hook up a traditional 150 watt transformer. And I'm going to have to get my amp probe ready. The 150 watt transformer, 150 watt transformer, they are not equal. They don't look equal. This is like rock, paper, scissors. Rock always wins. All right, so here we go. I'm going to put it on the secondary fast. Try to hook it up. $17.5, and it tripped. Of course it tripped. It's the advantage of having secondary protection. So we have 17.5 amps on the secondary. We had 12.6. This particular model transformer has a 15 amp circuit breaker. It can't handle as many. I need to go disconnect. So I'm gonna go ahead and disconnect, right down here, so it's all easy. I'm gonna bring it down into 28 lamps, so it's just this board now. Turn it on, and now on the secondary, I've got 9.6. That's a 15 amp breaker, it's a 150 watt transformer, so it's really a 12. I can really get 2 more amps on it, okay? So bear with me. I'm gonna throw 4 or 5 more lamps on it to get it up to its max, so it's only fair. Still overloaded, we've got 14.2 amps. We now have 12.9, still overloaded. 1, 2, 3, 4, 5, 6, 7. So there's 7 now. Now we have 35 lamps. We're at 12.1. Okay, so now we have 12.1 amps. So now we have really 12.1 amps. Check the primary. 1.3. So you can see that we had 50 lamps over here, 50. We have 35 over here. We're pulling the same amount of amperage, right? That's how efficient these high efficiency, low voltage transformers are. That's 15 lamps for free with the same electricity, all right? The other advantages, now we're going to go over quite a few. There's really 16 different advantages to go with a power supply versus a dumb transformer. Now, all AC magnetic transformers are dumb, all of them. All they do is they have a relative base, 120 in, 12 out, 130 in, 13 out, 110 in, 12 out. That's all they do. They regulate it through this normal set winding pattern. They do nothing else. Where a power supply that's intelligent does a lot of things. So the other thing is, which is kind of cool, is it's a different protection. This is a 120 watt transformer. So what I'm going to do is I'm going to go ahead and I'm going to hook back up all these other light bulbs. All right, so I hooked up 16 of them. I think I got 44, 45 of them. It's not a big deal. I'm going to just show you here why I'm doing that. If I can find my amp probe. So I know for sure probably I've overloaded the transformer, but the beauty about these transformers is they really have a no fault mechanism in there to allow, here it is, to allow really a no overload situation to occur, which is really cool. Now they're thermally protected, so if they get hot or there's some short in there, they're going to internally trip off and protect everything. But they can sense if it's a short or not. That's how smart these things are. So if you accidentally overload them with 6-watt bulbs or you accidentally put too many fixtures on it, they're smart. And they deregulate themselves. Super cool. So I've overloaded this, and if I take an amperage reading right here, I have 10.4 amps on it. I come over to here, and I got 1.1. All right, so I know just by doing the math, I shouldn't have that many. So if I come over here and I disconnect all these other fixtures over here back down to 28, right? So now, this is pretty interesting. I get 6.8. So what happened here by when I had those other 16, 18 lights on here, it didn't jump up to this height of 12.6. It stabilized at 10.4. It knew it was overloaded. It deregulated itself. It cut down the constant current, brought it down to 10 so it's in compliance, so it doesn't pop a fuse, it doesn't overload itself. Now that I've got the normal watts on it, I got 28, it's down to 6.4. So now if you take this and it's 6.4, now this guy is 6.4 amps on the secondary. Whoops, up here, 6.4 amps, right? This guy was 12.1, right? And then my primary is 0.8. So 0.8 on the primary, apples to apples basically, 0.8, right? 6.4 to 12.1, 13 amps on the second, or 1.3 amps on the primary, 12.6 on the secondary. We're talking 50% more efficient here, folks. It's mind-blowing. Now, some of the things, because I don't want to forget any, right? Here are the 16 things that are just mind-blowing about an intelligent power supply, right? It has regulated constant voltage. So if it's 13 volts out, it's 13 volts out unless you overload it. It'll always be 13 volts out. An AC magnetic transformer always drops a minimum of 1 volt at the transformer. That's how they work. These transformers, you're allowed to hook up between 80 and 300 volts. 277, 240, 208. Commercial jobs, electricians. It has an onboard power conditioner, right? LEDs are sensitive and they are smart. We cannot put them up and hook them up with a dumb magnetic transformer anymore. They need an electronic driver that conditions the power. LEDs don't like unstable voltage. They don't like 12.1, 12.2, 12.3, 11.9, various fluctuations. That's how a magnetic transformer works. They like constant conditioned voltage. Voltage is stable with no fluctuations. It's minimal. It has less voltage drop. Voltage drop's pretty much the same, but it has whatever that is, 20%, 30%. You can see the amperage. The primary amps are lower. What does that mean? Lower electricity bill for your homeowner. So now you have the most energy efficient system out there by 30 to 50%. Secondary, you saw it, it's around 40%. Means you get more fixtures on a run. I had 50 fixtures on this run versus 35 fixtures on this run. That's pretty cool. There's less heat on the LED. There's zero internal flickering. We've all been somewhere when we've seen a fluorescent light flicker really fast. Well, an LED's flicker, every one of them flickers internally, but we can't pick it up with our eyes. That is very hard on the internal dynamics of an LED. With our power supply that's conditioned, no internal flickering. They're thermally protected. They're FCC compliant. They're IP65, 67 rated. They have zero inrush current. For all you lighting guys that know what I'm talking about, we used to put thermistors in transformers and had all these headaches. No inrush current. It only draws the power that's needed. If I put an amp probe on this transformer right now, and I will, right? You will see that it was zero light bulbs on it. It draws 0.4 of an amp. Zero load. Went down to 0.3. Zero load. these transformers are not energy efficient, right? They're as old can be. There is zero humming noise. How many times have we been on and put a transformer on a bedroom wall? We've got complaints from the homeowners that it buzzes and vibrates. Zero vibration, zero buzzing. Yes, smart sensing technologies, which I went over about when you overload it. So those are the things that I can think of. I'm pretty sure there's going to be probably one or two more. Now, real quick, so you're going to get the fuse, you're going to get the hub, you're going to get a 25-foot wire lead, you're going to get the rock, you're going to get the in-use cover, and a timer if you order it. The wiring method, I'm going to come out with a different video within the next week to really explain it. But basically, you've got an in and an out that are connected into the fixture. And then if you have a dead end like this, you're going to have a tail coming off for an auxiliary lead, a hot tap, do something later, check your voltage, add a fixture, and then it's just going to be continuous. All this done here is all this here. It's all done in 18.2. So when you have a power supply system that drops the voltage 40 to 50% on the secondary amp, I'm allowed to run all of this through 18.2. So you're going to get a 25-foot lead from the transformer. You're going to use the fixture-to-fixture wiring. No more wire you're going to buy. My buddy Vince is going to hate me. Sorry, Vince. But anyway, thanks for paying attention. I'm going to have a lot more stuff to show you guys. Oh, buy my new book on Amazon, Lighting Bible and the Marketing Bible. See ya. Thanks for paying attention. Remember, directlol.com.